For decades, the battery industry has promised a revolution: longer range, faster charging, safer materials, and batteries that last not years but decades. Every few years, headlines appeared: solid-state batteries are coming next. Year changes everything. Lithium-ion is finished. And every time, nothing really changed until now, because for the first time in history, an all-solid-state battery is not just a lab experiment. It's not a prototype cell. It's not a limited demo for investors. It has entered mass production, and the numbers coming out of these factories are forcing the entire energy industry to pay attention. 5-minute full charging up to 100,000 charge cycles, non-flammable, solid electrolyte. Energy density far beyond lithium-ion operational lifespan measured in decades. This isn't a small improvement. This is a structural shift in how energy storage works. And today, we're going to explain why this moment is different, how these batteries actually work, and what mass production really means for EVs grids, and the future of power itself. Why lithium-ion has hit its limit. To understand why batteries matter, we need to understand what's broken. Lithium-ion batteries have powered everything from smartphones to electric cars for over 30 years. They're reliable, affordable, and well understood, but they have hard physical limits. 1. Flammability. Lithium-ion batteries rely on liquid electrolytes, volatile, organic solvents. When damaged, overheated, or short-circuited, they ignite. They enter thermal runaway, they burn uncontrollably. This is why EVs need massive cooling systems and protective casings. 2. Degradation. Heat. Charge damages the internal structure slightly. After 1,000 to 3,000 cycles, performance drops noticeably, and that's fine for phones, but catastrophic for grid storage and commercial vehicles. 3. Charging speed. Fast charging pushes lithium ions faster than the chemistry prefers. That causes lithium plating, internal dendrite growth, permanent capacity loss. This is why true 5-minute charging has always been impossible. Until now, lithium-ion isn't failing because engineers lack talent. It's failing because liquid chemistry has reached its ceiling. What solid state really means? The term solid-state battery has been abused for years, so let's be precise. A true all-solid-state battery means solid electrolyte, solid cathode, solid anode, no liquid or gel anywhere in the cell. This changes everything. Instead of ions swimming through liquid, they move through crystalline or glass-like solid materials. That allows higher voltages, tighter internal packing, no evaporation, no leakage, no fire risk. But solid electrolytes introduced their own problems that stopped mass production for decades. Solid-state failed for 30 years. Solid-state batteries are not new. They were invented in the 1970s cell. So why did it take 50 years? Problem 1. Interface resistance. Lithium contact is imperfect. Microscopic gaps form, increasing resistance and killing performance. Problem 2. Dendrite penetration. Lithium metal anodes grow needle-like structures that can pierce solid electrolytes for years. This caused short circuits even in solid designs. Problem 3. Manufacturing scale. Solid electrolytes were brittle, hard to shape, impossible to mass produce consistently. Apps could make one cell. Factories need millions, and this is where the breakthrough happened. The mass production bureaucracy arose. The difference today is manufacturing physics, not just chemistry. Recent solid-state factories use 1-sulfide-based solid electrolytes. These materials conduct lithium ions as well as liquid electrolytes, are soft enough to self-heal. Microcracks can be pressed at room temperature. This single change solved 3 historical problems at once. 2. Roll-to-roll production instead of batch lab processes. Manufacturers now use continuous lamination, dry coating, high-pressure stacking. This allows automotive-scale output. 3. AI-controlled quality systems. Every cell is monitored in real time. Pressure uniformity, interface resistance, crystal alignment. Defective cells are corrected during production, not discarded afterward. This is why the word mass production finally applies. The 5-minute charging. Explain. 5-minute charging sounds impossible, but here's why it works. In lithium-ion, fast charging causes heat buildup, ion congestion, lithium plating. In solid state, no liquid boiling, higher thermal stability, faster ion mobility paths, stronger anode electrolyte interface. This allows extremely high C rates without damage. The battery isn't being forced, it's operating within its safe chemical limits. That's the key difference. 100,000 cycles. Why that number matters. 10000 cycles is not a marketing number, it changes economic models. What 100,000 cycles means: daily charging for 270 years, continuous grid buffering for decades, EV batteries outlasting the vehicle itself. The reason is structural stability. Solid electrolytes don't dissolve electrodes, don't form unstable cell layers, don't suffer electrolyte decomposition. Each cycle causes near zero degradation. This isn't just better. It's a different class of battery safety. No fire, no oxygen, no NOx or ONA. One of the most important advantages is the least talked about. Solid-state batteries don't ignite, don't explode, don't release oxygen during failure. Even when punctured or crushed, they lose performance. They don't burn. This allows smaller battery packs, no heavy fire shielding, simpler cooling systems, which directly improves vehicle efficiency, aircraft feasibility, urban energy, storage safety. Why this enables electric AIRCRFT. Electric aviation has been waiting for this moment. Liquid lithium-ion batteries are too heavy, too fragile, too dangerous. Solid-state batteries solve fire risk at altitude, rapid charging between flights, long cycle requirement. Short haul electric aircraft become viable, not in theory, but in regulation. Impact on electric vehicle SEVs change completely. Range anxiety ends. Higher energy density equals lighter packs with longer range. Charging anxiety ends. 5 minutes feels like gasoline. Battery replacement ends. The battery becomes a lifetime component. This shifts EV design philosophy. Batteries integrated into structure, smaller packs for same range, more interior space. Grid storage and renewable energy. Why this may be the biggest impact. Solar and wind suffer from intermittency, degradation of storage system. Solid-state batteries allow daily cycling for decades, zero fire risk in cities, minimal maintenance. This accelerates renewable adoption faster than any policy ever could. Cost. The last solid-state batteries were expensive, but mass production changes cost curves. Key factors: no liquid electrolyte handling, less cooling hardware, longer lifespan reduces replacement costs. SAT scale, total cost of ownership beats lithium-ion, not immediately, but inevitably. Why this time is different. We have heard promises before, but this time factories exist, output numbers are verified, automotive partners are signed, grid pilots are operational. This is not a concept, it's infrastructure. The quiet energy or revolutionize, and this isn't like smartphones. You won't feel it overnight. But once solid-state batteries replace lithium-ion, energy becomes safer, transportation becomes cleaner, infrastructure becomes simpler, and for the first time in modern history, energy storage stops being the bottleneck. The world doesn't change in one headline, it changes when the technology finally works, and this time it does.